Hello, my name is Arnav Kari, and today I will be solving the LeetCode 2044 problem. The problem is quite interesting actually. It is a medium level problem, but yeah, it's quite interesting. You can solve this problem in many of the ways. I will be just solving this problem in a brute force way. Actually, the complexity is actually is going in brute force way. O of 2n. And in optimally, you can use memorization, that is by using a dictionary. You can just catch some of the repeated results. Um, the complexity is nearly the same, almost the same, but not the perfectly. It is much more optimized. But today I will just be using the brute force, right? So let's discuss about the problem. Given an integer array nums, right? Find the maximum possible bitwise OR. Hey, listen. What is bitwise OR? It is just an OR operation. Like let's take a number that is one and one. The thing is that is it's binary, one and one is three, right? And another number 101, that is five, right? So if in all operations, if one or one, the result is one, right? One or zero, result is one. So we can find that the maximum result that it can go in this problem is that one, one, and one. It is the maximum one, right? So, so let's come back to the problem. Bitwise OR of a subset of nums and return the number of different non-empty subsets uh, with the maximum bitwise OR. That is the subset OR, the OR of the element that is present in the subset should be equal to the maximum bitwise OR of the whole array. So the maximum I am taking it as the OR of all the element in the array, right? Uh, an array A is a subset of an array B. If A, it is the definition of the subset. It's very simple, right? Let's take the example actually. 3 and 1. The output is 2. Obviously, it will be 2, right? The maximum, if I or 3 means 1, 1, 1 and 1, the binary representation is 1, so the maximum is 1 1, right? It is the maximum. So the subset, if I take the subset 3, yeah, it is equal to the maximum OR, right? Let's take another subset that is 3 1. The same thing happens. I OR the both of the elements, it is 3. Let's take the example of here, example over here. The same thing. It is actually the same thing. You have to basically we have to use the decision tree. Each and every element you traverse, you have two options. You can accept that element or reject that element, right? As simple as that. Uh, Here we have to count the number of subsets that are equal to the maximum bitwise OR. The thing is that, and um, let's implement the code and let's understand the main logic. Let's first and foremost, we have to initialize some of the variables for this algorithm. I am just using the brute force one, so I am commenting over here. We are using us. So I'm just applying the brute force solution. Now I will be computing maximum or first and foremost I have to compute the maximum or, right? What is the maximum or? The maximum or of the array will be by ORing, by performing the OR operation with all the element. Let's take all the element. It will be the maximum OR, right? So let's take it. Um, Computing you computing the maximum or uh, let's initialize the maximum or max or is equal to 0. Uh, Now I will perform the main operation. I have to compute the maximum or. So traversing all the element and performing the and just modifying the maximum or value, right? For I in range, or I can do, oh, why I will use range, man? For I in nums, is nums, max or uh, sorry, is equal to max is equal to what is it? N, right? Okay. Now I should declare the result which I will be returning to the user, right? So res equal to why are putting, you know, sorry for the mistypings. It happens, right? So now I am computing the main result. This is the main part. Result, computing the main result. Now, thing is that basically I will be performing the depth first search. In if you already solved the LeetCode DFS problem, you can relate that. Yeah, in case of DFS, DFS actually the thing is that DFS is used for all the decently related problems, right? And the same thing happens over here. So we are just using decently, right? So depth first search makes sense. If DFS. So that means that I have to now accept I, that is, yeah, I. Um, I for actually the I is the position of the current element. Now, what will be the, and now I am also accepting the current number. URL, right? Into or just I will be performing the recursion operations over here. So accept that non sorry, non-local of race, comma, Mazor. If actually I am using this variables, so I have to provide non-local, right? Non-local race Mazor. Now the thing is that let's start with the base case. What will be the base case? Sorry, yes, base case. So what will be the base case if I is equal to when, oh sorry, when of when now, oh sorry for the mistypings. I actually I reached to the end of the list. So uh, now see now I am checking the conditions. Let's comment out. See, uh, I'm now checking the main conditions. If um, CUR NT or instead is equal to max or that is okay. That is correct. If the both of them are equal, I have to increment the result, right? This plus equal to 1. Ultimately, I have to return the number of subsets. Mm, that's the reason. Else, uh, just um, break out the if statement. Uh, TUR and return. So return. Okay. Uh, Now the thing is that now I have to think of the distance, right? So there are two cases. There may be two cases, right? Skip the current element or include the current element in the operations. So let me write it away. Which is- let's include uh, each element or is excluded, right? So I'll be performing the DFS from the next element I plus one DFS. Uh, so DFS I plus one. Sorry, I plus one. Four, six, one. Okay. I plus one, right? So I am now the first choice will be. No, I am not including the element over here. So, so the current all will be the same. Will remain the same, right? Current or you are taking the spelling is correct, right? Yeah. Now, I am including the current element in my operations. So, um, CURE or should be or with where is the or? Yeah, or with nums of I. Okay, nums of I. So, here is the main thing. This is the main computational part. Okay, I am done with the computational part. So I will be just calling into the body. DFS. I'll be starting from the zeroth element. Uh, 0, comma, 0. That is, I will be 0 and the current or that the current status of the or will be also 0, right? So DFS now return, sorry, is typing or return. Oh God, what I am typing wrong. Hmm. I was like, if I typed all the things correct, it should execute. Okay, all the test cases are passing. Okay, let's see, let's submit. Yeah. Basically, the time complexity is O of n square, and the space complexity is O of n. Right? So let's analyze it. Oh, shit. Okay. Yeah, basically the time complexity is O of 2 to the power of n and space complexity is O of n. So this is all about the problem. It's quite interesting problem. You can also use notation over here just by declaring some what to say dictionary and cache out some of the intermediate results, and while executing this part of this piece of code, while executing this piece of code, you can again use the results. So you can just use the repeated work during the recursion. But the thing is that the complexity will remain almost the same. Okay, so this is all about the problem. And yeah, I actually enjoyed solving this problem. Okay, I'm done. Bye.